Hi everybody, welcome to today's presentation. Today I'm going to be showing an overview of Carlson's software products. I am just recording this without an audience or anybody else in attendance. It's a makeup for when my computer crashed out last week when I was trying to do this. So my intention today is just to go through this. It's a little bit lengthy, but I'm going to touch on the Carlson software desktop products. Carlson Survey, Civil, Hydrology, and GIS. Those come with an included copy of IntelliCAD or can be run on top of your AutoCAD. So just a little bit about me. I do business as that CAD girl. I'm based in the Raleigh, North Carolina area. I have a long history, started off with DCA and AutoCAD 9 a long time ago. Went to Softdesk, Land Desktop, Civil 3D. I was a implementation certified expert for Civil 3D for several years with an Autodesk reseller. And then when I went on my own 2001, I figured that I would be offering training and support for Autodesk products. But Carlson came along, started building up their civil side, in addition to survey that had been around a while. And I became a fan, felt like it was a much better fit for my customers. We've kind of consolidated the industry now where Civil 3D and Carlson are kind of the only players out there really big. I am independent. I am fully on board with Carlson. I think it's the best option that's out there right now. But I speak for myself and I speak for my customers. But I have a great working relationship with Carlson and have for several years. So for those of you that don't really know anything about Carlson, if this is an introduction, I just want to start off a little bit here, if I can get everything moving. A little bit about Carlson. They, as well, are privately owned. They're independent. They are family owned, and a lot of Carlson's in the business. Their main office is in Maysville, Kentucky, and they have programming offices in Boston whenever anybody else can get back into the office. A lot of people working from home regardless there. But they don't have stockholders, and they really are just responsive to their customers. Like I said earlier, the desktop software comes with IntelliCAD, which is a generic version of full AutoCAD. It is more like AutoCAD as opposed to AutoCAD LT. Carlson 2020 can run on top of the IntelliCAD they give you or on top of a full license of AutoCAD. For 2020, it'll install on top of any AutoCAD version 2015 to 2020. I think when Carlson 21 is released here in a month or so, it can run on top of 2017 to 2021. Again, any full AutoCAD that you have, so that would be AutoCAD or AutoCAD Map or Civil 3D, any other of their verticals. So Carlson just uses the CAD platform underneath. It's not going to really use the Civil 3D. It doesn't need it. And again, IntelliCAD is open source, so Carlson develops on top of it, and they work with the consortium to try to make IntelliCAD be as good of a comparison to AutoCAD as it possibly can be. Next month, or actually this month, we have Dave Lorenzo with the IntelliCAD Technical Consortium, who is going to present an IntelliCAD webinar with some people from Carlson. So if you're watching this recording, you can also look for that recording that I will post after it happens. Carlson offers flexible licensing, so they're kind of the anti-Autodesk in a lot of these cases. Autodesk has gotten away from perpetual licenses where you buy it once and can use it forevermore. Carlson still has that. Autodesk is going away this month, going away from network licenses and phasing those out. Carlson still allows that. It is a really good option for a lot of people to stretch their software budgeting. Carlson offers maintenance, so it is optional, but maintenance is 10% of the cost of the retail of the software per year keeps you up to date with that. And then each license of Carlson permits 2 installations. So you can install it in your office on your desktop computer, and you can install it on a laptop that you may take to the field. Carlson does not really stop supporting any of their software versions. So if you still have it and you have it installed, you can call in to them for support. So they're going to support all their previous releases and does not retire their software. And like I mentioned, they do have free technical support. So you can call in. You'll either be routed to the Maysville or Boston office or a home office. But everything is free, whether you're running a trial of the software, whether you're current, whether you're not, it really doesn't matter. They do get backed up, and sometimes it can get frustrating, but you can email them, you can call them. If you're a customer of mine, I always encourage you to, hit up both of us if you have a problem. If you're emailing, copy both of us on the email, and whether it's Carlson or me that can get to you quicker, just the more the merrier, right? So, but it also really does keep Carlson in touch with their customers so they know what's working in the software, what's not, what updates are being requested. So one of the approach that Carlson takes is to make all of the entities that they create in the software be as available and accessible to as many people as possible. So through the course of today's presentation, you're going to see some dynamic reactions and different things that look like Civil 3D or even Land Desktop did. However, Carlson doesn't create unique entities to do that. All those dynamic reactions are going to happen with polylines, with text, with blocks, with attributes, just plain CAD entities. And that just ensures that when you're working on a DWG file in 2020, if you have to send that to somebody that has a really old version of AutoCAD 9, they're still going to be able to read what you produce. So it's just a different approach. Carlson keeps those things basic so that everybody can use them. And then Carlson plays well with others. This ties into the last slide as well. They just want to be compatible with as many people as possible. They're not going to, lock their information and their data down to where you are limited on what software you can use in the future. So everything that they have, there are so many menus and so many options to import and export to different file formats, and I'm going to show you a little bit of that, that Carlson just makes it easy to work with others regardless of what programs those other people on your project team may be using. And then importantly, what's the cost? So this is just retail pricing. It's relatively, seems to be quite a bit cheaper than Civil 3D. The bundle that you would probably try to use as a comparison to Civil 3D would be what we call the Civil Suite. And that would be Survey, Civil, Hydrology, and GIS. And that's what I'm going to focus on today. But you can see the Pick 4 bundle. I always have discounts. Like I said, I'm a reseller. So you can purchase from Carlson directly, or you can purchase from another reseller or from me. I try to do value add for anyone that purchases from me. So I do webinars, 2 or 3 or 4 a month on different topics, and they're live. So I do try to support what I sell. If you have any questions, feel free to follow up with me. And with that, let's just go ahead and look at the software here. All right, so on my desktop, I just want you to see what the icons look like. So on the one icon that I have highlighted, you can see I've installed Carlson Civil Suite 2020 with IntelliCAD. When you purchase the software and you go through the installation, it's going to ask what the platform is. So you're going to have an option for IntelliCAD always. And then if you have AutoCAD, rather than choosing IntelliCAD as a platform, you could install on top of your AutoCAD. So you can see here I've got 2020 with IntelliCAD, and here I have Carlson 2019 with AutoCAD. So after I installed 2020, I never actually bothered to go back and install it on top of AutoCAD because I've been fine with IntelliCAD. But this is what you'll end up with. If you purchase, I recommend that you go ahead and install, if you have AutoCAD, install on top of your AutoCAD, and then rerun through the installation with IntelliCAD again. And that way, for whatever reason, if you have trouble with AutoCAD, you could get into IntelliCAD and keep working with it. Okay, so this is the program. So as far as the user interface, you can see that I have my menu bar across the top. I've got some toolbars open. There is a ribbon. I am still pretty old school. Learned a long time ago. Very comfortable on the at the command line. I also work from a laptop a lot of the time, so I tend to keep this as much drawing area as I can with just a few toolbars. So again, I do have the menus across the top. So regardless of what program you're in, the first 7 menus are going to be the same. You can see here, this is Carlson Menus Toolbar. And the first one here is for survey, so that's what's currently loaded. But the menus from file over to points are going to be identical regardless of which program you're in. So you always have access to that core set of menus. Once you get past points, the menus are going to be a little more specific to whatever program you have loaded. Sometimes they'll be unique to that program. So you can see in survey here, we have a survey menu, we have a COGO menu. They're pretty much specific. Those two are to survey, but I think a lot of the commands are also in takeoff or construction. For instance, Centerline, area layout, and Annotate are all also going to be in the civil program. And then the surface menu in survey, there is a surface menu in civil as well, but it's a little bit different. So here in the surface menu in survey, you can see at the bottom, we have one little section that's all profiles. However, if we switch to the civil menu, you can see there is a full surface menu, but there is a totally separate profile menu, okay? The uniqueness here in civil is going to be 3D data. We're going to talk about that. And then SiteNet. And then you've got a lot more of like roads and different things here. And so again, today I'm going to show you things in survey, civil, hydrology, and GIS. I'm going to switch back to survey. And then before I get too far off of this, I do want to go back to what I mentioned earlier about Carlson playing well with others, and just point out all of the import and export routines that Carlson gives you. So under File, so it's a menu that you have in every program, you can see all of the different import options, and you can see Civil 3D here. So all of this data can be extracted from a Civil 3D DWG file and brought into Carlson. I will say that, there is a little bit of a lapse when a new version of Civil 3D comes out. Carlson has to build their software so that it knows how to extract that information out of the drawing. So the further you get in the release cycle, so we're right at the end of 2020 here. So we've pretty much gotten everything out of Civil 3D that we can up to 2020, and so you're gonna probably be able to bring that in pretty flawlessly. And then when you export, you can see Land XML is pretty much the preferred format for everything. Google Earth, you can export to a Civil 3D. So these options under File are in addition to different formats you've got under each like point menu. If we look at the bottom, we can convert to Carlson and from Carlson. If you look under surfaces, you can see we've got other options. So anyway, I just wanted to highlight that because I think, we're all passing files to and from other people, and that ends up being one of our larger headaches. So before I start in my first drawing file, let's just mention quickly our project and data files. So under project setup, I'm going to say that we have really two different data folder setups that we can use. Drawing folder is going to be good for most simple projects. When I say simple, that would be a project that is going to primarily consist of DWG files, of course, maybe CRD files for points, 10 files for surfaces, okay? If that's what your project consists of, a drawing folder is going to be good. A drawing folder wants you to have one folder for your project information. The first thing you do when you start a new drawing is you save that drawing in the folder. And then from that point forward, when you have to open or create any new files while you're working in that drawing, it's going to default to the same folder where the drawing is saved. That's the drawing folder method. For what we're doing now, I'm going to leave it at this. A little bit later, when we get into doing some road design and center lines and profiles, I'll switch that over and talk more about the project folder method. So let me start a new drawing with a Carlson template file. Drawing folder method, first thing I'm going to do is set my folder, and I'm going to put today's date, and I'll just call this Survey 01. Now I know that I'm going to try to bring in a background image here shortly, and so right when starting the drawing, I'm going to set the projection and zone so that everything is geo-referenced. You can see here on this wizard, the first screen, I can set a horizontal scale and some annotation. And I'll pick next, and here I'm going to tell it that I want to import a text file into a brand new CRD file. Because I'm using the drawing folder method, it knows that the data path, or the folder it's going to save in, is wherever my drawing is. And then it's got my CRD file name. So the wizard just puts me right into my next step, which is importing my text file. It's looking in the same folder where my drawing is, and I had a text file. I can select it, and then I get data preview here. So it shows me the first 100 lines. Hopefully I can tell if I'm in the right file or not. And then back here, I can specify the format, comma delimited, space delimited, what have you. Another preview, and then when I draw points, I'm going to choose to use the Draw Locate Points command, which is one of the commands that's in the Points menu, so everybody has it. We'll pick OK. And then the Draw Locate Points dialog box, it is pretty generic. It lets me set one symbol, one layer, kind of the same settings for everything is how I'm going to use it. So I'm going to use this command and draw all the points into the drawing. And so here they are. I'll go to my layer manager, and you can see it looks very similar to AutoCAD for those of you new to it. I'm just going to set my elevations to cyan, and then we can scroll in and take a look. So these are just point blocks. So it is a block or an insert. IntelliCAD calls a block an insert as its type of entity, with attributes for point number, elevation, description. Okay. If I double click on a point, That's a quick way to pull up the editor. So I can see, I can view, I can edit anything about that point. I've got a button here to see the history. So if I had modified it or manipulated it in any way, I can see what's been done to that particular point. I also have options to undo some or multiple commands. I can change the symbol or see it if I have any GIS data associated with it or an image. So if this is a field located shot and a picture was snapped, I can attach that or see it. So some of the basic point management commands, if I want to list points, I can do so here. This is Carlson's kind of a text editor. It's like a notepad. So you can see all of the points. You can save it, you can print it to the screen, whatever. Or if I actually need to edit points, I can pull up this dialog box, and you're actually working in the CRD file. You can double click, you can edit anything. There's also a find and replace function. I'm just going to close without making any changes. So again, under the points menu, you can pretty much do anything you want. There's a ton of utilities and different things that let you edit the file or edit the points on the screen. Coordinate file utilities is kind of a good little catalog to go in here if you're not sure where to find something. So the left-hand column deals mostly with the file, the CRD file edits, and then the right side is more for on-screen. So I want to show you one other, I guess, a property of points. And one of the best ways to do that is to use this command called shrink wrap entities. Excuse me. So this is a command that's primary reason for being is to help you create a boundary around points or lines for a surface. So when I go in here, it's going to create a polyline, 2D polyline, on that layer around whatever I select. And so you can see I'm not being very specific. I've just put a window around everything. And you can see that shrink wrap polyline catches everything. So this is really with no preparation work. It's not looking at any points to figure out what's good for a surface or anything. This is the shrink wrap that we get. I'm going to erase everything, and then I'm going to use Carlson's Field to Finish feature to redraw everything back in. So Field to Finish is specific to survey, but it's also in construction. It's in takeoff. When we drew points with draw locate, it treated every point, regardless of its description, exactly the same. Same symbol, same layer, same everything. When we introduce field to finish, we can get specific on how points are inserted into the drawing based on their description. So it's going to handle a point that has oak as its description, which would be a tree, and I'd want a tree symbol and maybe on a certain layer, differently than it would a point with a description of BOC for back of curve. A BOC I would want on a different layer. I would probably want a 2D polyline to show on my sheet. I would want a 3D polyline for the surface as a break line. So Field to Finish, if you're using Land Desktop or Civil 3D, it's going to be comparable to description keys and the automatic line work functions in that program. All right, so let's just make sure I've got the right file set. I didn't think so. Let's see, existing. So this is my FL. Oh, nope. There we go. All right, so this is my FLD file. I'm just going to draw everything to begin with here so that you can see what we've ended up with. So when I zoom in, you can see that the points, most of them look different. You can see I've got symbols here for my trees. I have line work that's been drawn. At the corners, I have different symbols again. Let's just look at this in 3D. And you can see that I have line work and points that are elevated. So again, this is kind of a step that I want to take before I build a surface. I want to look at everything in 3D to make sure my elevations are good. Now, what this 3D viewer allows me to do is ignore zero elevations, so that's how it was set. Now I've unchecked ignore zero elevations. When I zoom out, I can see everything with zero elevations down here, and then everything that's elevated up here. When I build my surface, I'm going to be able to just put a check mark and ignore all the zero elevations. So my main thing I want to look at here is that I don't have any really skewed elevations, and I don't. I can also look at this with the layer inspector, and let's see what field to finish has drawn for me here. I'll scroll down a little bit. So layer inspector is isolating and zooming to whichever layer or layers I have selected in this list. So field to finish has drawn buildings on layer V building for me. Those are 2D polylines. Centerline, ditch centerline. If I hold my shift key down, I can select all of these layers that start with V nodes. So I see all my points are now sorted out onto different layers according to their purpose. I have 2 layers for road centerline and edge of pavement. And then here on this layer, these are all my 3D polylines. So these are break lines for my surface that I'm getting ready to create. And then finally, let's look at that last piece of the puzzle that I mentioned earlier. Let's draw shrink wrap, and I want you to see the difference in how the shrink wrap polyline looks now after drawing everything with field to finish versus before. So here's my 3D polyline, my 2D polyline, which is my shrink wrap. Notice that this time, for some reason, it's ignored all of this. And right here is the best example and place to demonstrate what's happened. So if I pull these out, you can see the shrink wrap actually has included my ground shot, but it's skirted just around my iron pin. It's avoided my iron pin here. So these are property corners that I know typically anything with that description is going to be a property corner, and the elevation is not going to be good for my surface model. I don't want it included when I build a surface. Same thing here. So one thing that's built into the shrink wrap polyline command, it ignores anything that's considered a non-surface point. Okay, great. So why are these non-surface all of a sudden? Well, I did that with field to finish, but if I double click on this point, you can see here it's been tagged as non-surface, and I did that through field to finish. So a ground shot is not tagged as non-surface, so in other words, it will be used for my surface. This out here, it is a non-surface. There are going to be other things that are like interior, like this hub, that is a non-surface. Under the surface menu, triangulation, setup, utilities, non-surface points and entities, report non-surface points, I can actually see a list here of all the points that are being ignored by the surface, or by the shrink wrap, and when I build a surface, these will all be ignored. And then let's just go into field to finish. I'm going to edit those codes so you can actually see how that comes into play. So ECM, right here, I've got that check mark. Anything with an ECM description is going to be tagged as non-surface. It'll be ignored by my shrink wrap and by my surface model or anything else that uses it. While we're here, let's just look at our center line of ditch. So here's a good example. Center line of ditch shots are going to be drawn, they're always drawn with points, but in addition, 2D and 3D polylines. This is the layer for the 2D polyline, this is the layer for the point, and then here are my 3D polylines. That's going to have just a generic symbol. Let's look again, should have stayed in here for the concrete monument. It's considered points only, we're not going to have any line work. This will be the symbol layer, this will be the point layer. I can specify the symbol here. So that's how field to finish works. It does take some setup. There are options if you're coming from Civil 3D or Land Desktop that you can import your description keys. Not there though. Civil 3D codes. I think description keys are in here. Land Desktop keys. There you go. Okay, so this has all been drawn. I'm actually going to erase this shrink wrap. I always recommend before you build a surface, draw your shrink wrap, see what it looks like, and then you can erase it. Also look at everything in 3D, make sure your elevations are good, and they are. When we're ready to build a surface, I'm going to go to Triangulate and Contour. And if you look right here, shrink wrap is actually built into this command. So the reason you do it ahead of time is to make sure that boundary is what you expect. And then you can erase it knowing that when you come in here, you're going to get the same result. Okay, so let's start at the top on the Triangulate tab. We're going to write a triangulation file. And yep, that's the right place. And we're going to just call this EG. Let me put today's date on it. And we'll just call it EG. Right here, I have told it to ignore anything with a 0 elevation. So that means I'll be able to put a window around everything here, and it will only pick things with good elevations. I'm going to uncheck these, we'll check them back later, but these are adjustments if you're building a surface from contours in the drawing, which we're not. We will draw new contours here, so 1 foot contours and 5 foot contours. We're going to label those, and then my selection tab, I am going to choose all points and all polylines. Window around everything, hit my enter key, and when I zoom in, you can see that the surface has created contours. It's built the surface and it's drawn the contours for me. If we go to our 3D viewer window, now we can look at the surface file viewer, which lets me select the 10 file, and this is what the surface looks like. Over here, I can turn on and off the shading, okay? But I can spin it around. I can see, my work that I did ahead made sure there was no bad elevation, so my surface is good. Okay, I've also got contour labels. So like I said earlier, everything that Carlson does, these are just, it's polylines and text. Okay, this is long, with a wipeout. So Carlson has built in the ability to do some of that cool stuff like we do like from the special contours that Land Desktop or Civil 3D creates. We can still do things like that. Carlson just keeps it in generic CAD entities. And let me double check here. I think that's all I wanted to do in here with our surface. So now I want to bring in a background image. Okay, so I have some options. If I just want to bring in an image and I'm okay with having to position it myself, rotate it, scale it, what have you, I can do that without a problem. It's in the Draw menu under Image. So this is just the way you insert an image in plain CAD. It's in the Draw menu, the first 7 menus, everybody has it. However, Carlson's GIS program has some really easy, handy tools to bring in geo-referenced images. So we are currently in Carlson Survey, and let's just look. Carlson Survey has a GIS menu. So this is just one menu. It's got limited functionality. You can bring in a few kinds of images. So you can bring in Mr. Sid images. You can place an image by a Word file if you have Carlson Survey. Okay. Also in here, you can do things like importing a shapefile. So what I'm talking about now is actually this would be another module, a different program, is the Carlson GIS program. So I have just loaded the GIS menu. You can see after the first 7 menus, you can see that you have GIS data menu, GIS tools, and then the all-important images. So this is where all the cool stuff is kept. So from images, you can see those other things. So you can convert a Mr. Sid, you can place by world file. But we can also do things like place a Google Earth image. So I am going to just name this Google Earth. I'll screen pick my window. I barely made it, didn't I? And there we go. So you can see the Google Earth image. Usually this is going to be probably the newest imagery that you can get. Another couple places where you can bring in other imagery is under GIS data, Esri Arcgis services. So this can be a little sporadic as far as what you can get from it and linking up to the Esri servers. But if you want like a quad map, you can do that. You can bring in images of soils maps and things like that. We'll call this Esri, and this one takes a little bit longer. And it'll come. There we go. Oh, well, let's see. Let's move this to the back. There we go. So this is like a quad map. Let me freeze those here for the moment. Also, I guess I will mention, if you do place web maps service image, this is Carlson's version of the same thing for Esri that we just looked. You're just using images on Carlson server. So they've given you a lot of the same things. You can also use this to attach to like your local municipalities database if they have available imagery. Similar to that, web feature service, if your municipality has a server that you can attach to and get all that data, you might be able to take advantage of that. And then back in the file menu, let's just look at, I mentioned earlier, exporting to Google Earth. So if you're in any kind of a design role and you are designing something and you want to send this out to your client to let them see the subdivision layout or what have you, you can also select anything in your drawing and export it out to Google Earth. All this requires is that you be in real-world coordinates, and then, like we did at the very beginning, we set the zone and projection for a project area. But you can see over here, you've got all your layer information. We can zoom in, but this is a good way. All this is a file. So it is a KML or a KMZ file. There it is. So you email that to your client. They double click on it, and if they have Google Earth installed, they're going to get this exact same view. So it's very handy as a design tool. Okay, so let's move on. I think I'm actually going to close out of this, and I'm going to restart Carlson because I got a video display error. So I've been having all kinds of technical problems here lately. So I'm going to hedge my bets a bit and just get out and get back in. Okay, so there's my menu. I'm going to switch back to survey, and I'm going to start a new drawing. And I just want to show you how to enter deed information or information from a plat. So I'll go into this folder and set a new file. So we'll just call this deed. Scale's fine, projection, this is going to be assumed coordinates, so I'm just going to hit exit here. So I'm just working in the drawing. And I want to create just a very simple little example for you. I want to be sure that you understand that if you're going from a deed and you just have a bunch of boundary calls or from a plat or whatever, there are many different commands throughout the program that let you do that. If all you want is a polyline in the end, if you want to do it by, northings and eastings or bearings or azimuths or turned angles or deflection angles, however you want to do it, there are multiple ways. The example that I'm going to use here is entering a deed description, and it does have an external file that it attaches to. The reason I like to do it here is because it's very forgiving. Even though my example is going to be very, very simple, I think about using this if you have a plat with a whole string, maybe you have a line table with a whole string of calls going down a creek line or around a wetland area, and it's very easy to make a mistake. It's very easy to skip a line or to put one in twice, so I like this because it's forgiving. This is under the survey menu and enter deed description. So again, it does require me to create that PDD file, which is fine. So here, it's going to draw my lines and curves on this layer. I am not going to do points because I want polylines only. If I want points, I'll add them later. I will have it, this will be lot number 1. So this deed file can actually have multiple deeds inside of it. So you can have your subject property plus all the adjoiners. I'm going to have it draw the line work, create a polyline as I do it. So I'm just going to pick a starting point in space and go very easy. Northeast quadrant, 45 degrees for 200 feet. So you can see the format. That Q is for quadrant, two characters for degrees, a period, 2 for minutes, and then 2 for seconds. So I'll go southeast 45 for 200 feet, southwest 45 for 200 feet. And then this may mess you up. I'm going to go actually due west, so that'll be a southwest 90-degree bearing for 50 feet. And then northwest 45 degrees for 200. So kind of the example that I'm using here is there should have been a flat spot up here. And we accidentally on purpose forgot it. So the thing with doing this as a deed description is that it's much easier to, if you already hit enter and realize a mistake, just keep going. It's easier to go back at the very end and fix everything. It's much easier to do that than to try to undo or kind of stop in the middle. So I'd encourage you just to go on. I'm finished here, so I'm going to hit an E for exit, and I have a beautiful, fantastic 1 in 17 closure. But now, I can go in here to process deed file, select my file, and now I can edit that. And this is what I like. Again, picture having, a list of 100 different calls. In the table up top, I can select on one of the legs and it highlights it in the drawing view below. So as I go down, if I had a mistake in any of these lines, I would know which one to fix. In this case, I accidentally left one out, so I can add, and I can just give it the length and then set my bearing and the angle, and you can see that new line. Now it's here because it's at the bottom of this list. What I want to do is move it up until it gets in position. So it's moving up this list, and that's where I want it. Okay. So it's very easy, very forgiving. If you've got curved data, you can do that. You can see here we've got an option for arcs or lines. Now starting easting, I'm going to go ahead and just force this into 5,000, 5,000 as a POB. Here I can re-report things now that I've fixed it, so I've got a much better closure. I want to redraw this, so I've got the wrong one in the drawing, so I want to redraw. It's going to erase the previous one. Label lines and arcs. So from here, it's just going to put in kind of a generic labeling that we can see here in what's called Annotate command. So right now, Annotate has one labeling format for lines, and you can see it here. It's going to be angle above and distance below the line. For arcs, if I had any, it would just label it the same way for everything. So that's good as a generic starting place. And then I can save and exit out of here and see what I've got. So I've got all this labeled. Let's look at Annotate again. So under Annotate, Annotate, it's the same command, but maybe I wanted angle and distance both above the line. So up here, angle, distance, I'm going to set distance above. And if I want them side by side, that's fine. Or if I want my distance to be above. So I can set this however I want. And I've only got one polyline, but I could put a window around the whole subdivision if I want, and it would label everything. Let me go back in there because this is also a good way to go ahead and specify line tables. So Carlson gives you options for using line tables and curve tables. You can set it here to never or always or by scalar. If you do it by scalar, you can set a distance here, and that's going to be in plotted inches. So if you do it by scalar here, anything that's shorter than an inch would go to a table. Anything that's longer than an inch would be labeled on screen. And you can see the same thing here. All right, so Annotate's good to put labels on everything in one fell swoop, but maybe your outside boundary lines, like your outer boundary, you want to label differently. If you want to just do a few lines here and there that look different, you can do bearing and distance. And notice when we did Annotate and selected this, it did all the legs of the polyline the same. But if you just go in here and specify one angle and distance label format, it's just going to do the one segment that you select. We've also got annotation here where you can move a label with a leader. So maybe it's just a little bit too short, but you don't want to put it on a curve table, or maybe it's the only one. You can do something like that. So with their annotation, Carlson gives all kinds of options. Again, there's so much more in here that I'm able to get to, but hopefully that gives you a taste of it. Okay, close that. Let's open up and look at, oh, I was in the right place. So I want to show you Carlson's LotNet routine. So this is Lot Network, and this is a way to subdivide a large area using a certain set of criteria. So Carlson's LotNet is available in Survey or Civil, and I think the other maybe Takeoff. And you can work with LotNet in a couple of different ways. You always have to have the outer boundary, but then as far as the roads that are internal, you can have the roads drawn in two different ways. You can see here I've got a center line, and then I've already done my offsets to create the right-of-way. So that's something I did ahead of time, and I can start from here. LotNet also has an embedded 2D version of Carlson's RoadNet program that, if you would prefer, you can start with your outer boundary and just the center lines, and then through the course of doing LotNet, you can also have the RoadNet piece draw all your offsets. So it can do your edges of pavement, sidewalk, right-of-way like you see here. So you can do it one of two ways. I'm not a huge toolbar fan, but with Lot Network, it does make it very easy. It's just one easy little toolbar going across. So I'm going to start here with my Lot Network settings. It does create an LTN file, so that's my Lot Network file. And with this, so that's my Lot Network. I'm not using a road network here because I've got my rights of way already drawn in. Automatic labeling, so it's going to draw my lot lines. I am going to have it draw building pads. So these are just kind of generic for graphic purposes. So I'm going to have it draw building pads that are 30 by 30. You can have it do a lot fit. So if you have different footprints, you can see what fits and what doesn't. I'm not going to use it like that today. But up here you can see the lot setbacks, so I can put in my front, side, and back setbacks. I'll have it draw the setback polylines for me. And somewhere else, when I have it subdivide out my lots, it'll measure my minimum frontage using those setbacks. Okay. Label lines and arcs, I'm going to have that turned off for now, but all it does is use auto annotate that we just saw. And then I'll have it label areas for me. So on the toolbar, the next thing is to set the boundary. So I'm going to select that closed outside boundary. If I had a road network, I could change it here, but I'm not going to use that. Add my right-of-way polyline. So if I'm not doing it as a road network, I have to be able to select on my right-of-way polylines. Okay, so now it has its enclosed areas to subdivide. So I'll start over here, subdivide area. And I want to set this up. I'll pick inside lot area to subdivide, so I'll select here. So my first thing here, it's kind of like I talked about with auto annotate. I want to put in my lot settings to do a whole bunch at one time, see how they work, try to get that consistency for as many as possible, and then there's going to be a few that don't work, and I'll go back and tweak those as I go. So as a starting point, I'm going to have it draw 15,000 foot lots. Minimum frontage is 100 feet to be measured at the setback. I can set my minimum, maximum depths. Remainder is going to apply equally to all lots, so everything should be a minimum of 15,000 feet. And then when I check that building placement, I can just recheck all my setbacks here. All right, so it highlights the road right-of-way, and I'm going to start drawing from this side. And it's going to pop all those in, and so starting from that, it looks fine to me, except for this area needs some work. So on this toolbar, we've got buttons to add a lot edge or a lot line and remove a lot edge. So you can't just erase. What I want to do here to make sure the network is preserved is I want to use that button to actually delete those lot edges. So it recombines everything, draws these. But now I can, because I'm more comfortable using polylines, I'm going to set the right layer, and I'm going to start with a polyline. And I'm just going to use my object snaps to snap here, and then snap perpendicular to the right-of-way here. And then I'll snap to the center point, and then a nearest point here. And I'll just trim that out, clean it up. So I've got these polylines in. I need to just define those as lot edges in my network, and I can do that here. And you can see what I end up with. So again, there's a whole lot more that you can do. You can report, you can number, renumber, put everything to a table, export it however you want. Let's take a quick look under area layout, and you can see under lot network all the different things that you can do. You can define sub-areas, so if you have areas of poor soils or open space that can't be included in your watch, you can tag those and separate them out and report them differently. So there's a ton of things that you can do. I just don't have time for on this, but that is Carlson's allotment. So next I want to show some grading tools. So this is what I call my little sandbox. So it's just a demonstration drawing to show you a bunch of different commands that are available in Carlson, because they can, when you get to site grading, there's so many different things you do in so many different orders. I have other webinars that go through these, like go through a whole site project grading. But I think for today, I just want you to see the tools, and then you can kind of be creative, and I think a lot of people will understand how those can be used. So these are going to be tools in Carlson Civil. So I'll pull that menu back up here. So I'll switch to Carlson Civil. And these commands are going to be under 3D data, mostly under 2D to 3D Polyline. So a lot of times, most of the time with grading, we're going to have our features drawn in 2D polylines. And then when we get around to grading, we want to convert those to 3D polylines with elevation to represent the grading. And so that's what this menu lets you do. So let's zoom in here and let's just look at this example. I'm going to turn on Drawing Inspector, and you can see that I have 2D zero elevation polyline here on E road back of curb. These points are set on vertices of that polyline, and this is just a 2D polyline. It's just got an arc in here. But what I want to do is elevate and create a new polyline and elevate it using these elevations. So I'll use 2D to 3D polyline by points, and ask for CRD file, that's fine. So I want to keep my existing polylines and put the new polyline on this layer. So watching the command line, select polylines to convert, enter, and then select the points. I'll just put a window around it, and you can see it's changed. If I look at that polyline in 3D, you can see it here. I'll zoom out. So here's the 2D zero elevation polyline, and then here's my 3D that's been elevated now. So I'll show you this. Kind of the primary purpose for this one is just to see that we have 3 different polylines. These are just text. I don't like this. I don't like this method. Main reason is because, it's pretty, hard to understand what part of the text is going to elevate how close it has to be to what part of the polyline. So it's not real clear. Is it going to be this vertex? Is it going to be the closest part? Who knows? So I just wouldn't recommend this, but I am going to do it just so you can see. I've got 3 different polylines. I've used one of the Carlson tools to just change the elevations by 100 on each. So anything that I'm showing you here can be done on like an entire Target parking lot, if you're trying to elevate islands or something. So this is going to be 2D to 3D polyline by text. So watching the command line, select a sample of the text, sample of the line or polyline to convert, and then I'm just going to window everything here. And it elevated the actual ones. It didn't create a copy for me, but you can see that did work. So if you're going to do this, I recommend this option or this one. So this is by text with a leader. I like this one because just like with points, you know exactly what location on that polyline is getting elevated. The other advantage to doing points or like this with a leader is there doesn't have to be a predefined vertex for it to know what it's elevating. So, I can just, there's not a vertex there. I just snap to it. And let's make this a foot higher even. And then the other kind of intricate part of this is that we have two elevations pointing to the same location on the polyline, and how does the software know what to use? So let me show you how that works by text with a leader. Select a sample of the elevation text, sample of the leader, sample of the polyline to convert. I'll put a window around both of these. And then it comes up and it recognizes there were different prefixes and asks me which one to use. I'm going to use the back of curb elevation. And so it has done so. If I click here, you can see it's inserted that vertex, high point. It's elevated all this for me. If I look at everything in 3D, oh, I had a 0 elevation. Oops. Oh, did it not do one? Oh, they're just different elevations, that's why. Okay, well, bad example. But you could see everything was elevated. I confused myself there for a second. So these two polylines have different elevations. This one's at the 90 level, and this is up in the 200s. Okay, so building pads. Let's say you have a whole subdivision. You've got 0 elevation building pads, and you have labels showing finished floor and subgrade. Under 3D data, this one's here, pad polyline by interior text. I'm going to have it put the polyline, 3D polyline, on its own layer. So it asks me to select a sample of the elevation text of the boundary line work. Select all. Again, it found 2 pieces of text with different prefixes. And here it's created that 3D building for me. And then in Civil, you also can go the other way, so you can know how I cheated here. So these are elevated buildings, and under Annotate, label Polyline, is that it? Yeah, no, that's not it. Ah, I just got lost. Oh, label polylines, there we go. Label pad elevations, so you can see it's still set up. I've got a FFE, and then subtracting 8 inches to label my subgrade, and I can do that. Okay, so let's go up here. I want to focus now on this one. So here's another building pad with a 0 elevation, back of curb with a 0 elevation. So I'm going to use just a different command for no other purpose, just to show you something different. If you have just one polyline, you can also do this by selecting the text. So I'm going to select that text and then select the building pad, and it's just maybe a little different, so get the same result. But now I want to elevate, in the end I want to elevate this curb, but you can see it's got 0 elevation. But I want to show you one of the other tools in here to set points on this curb so that eventually we can do something like this. So 3D data, 3D points, points by slope. So I want to enter my slope as a %, and I'm going to screen pick my location. So my reference point, I'm just going to snap nearest to this elevated pad. You can see it reads the elevation. And then my new point is going to go here. The slope is going to be a -2%. And the description is going to be BC for back of curb. So you can see the elevation it used. So I want to set a point here as well, and I want to come off the building. So I'm going to change my reference point to here, and then set my new point here, and I'll go at a -3 here. So this is just a grading tool. Now I've not committed to anything. I'm just setting points based on slopes from other points on my screen. If I want to, let's say I want to come from point 2 and I want to set a point here, I could do a screen pick and it's going to calculate the slope straight line distance from here to here. Or I've got an option to follow the polyline, so it'll calculate the slope along a longer length to give me a different elevation. So my reference point in this case would be point 2, and my target point would be here. We'll go up at a +2, follow that polyline, and that's the elevation I get. So I can use this as a tool for setting these points, and then go back 2D to 3D polyline by points and start elevating my 2D polylines to 3D for grading. Okay, so I think I'm done with grading here. So I want to move on next. I'm going to show you how to do just kind of generic center lines and profiles. Just manually. Let's say you've got a single center line of a road or whatever. And then we're going to move into RoadNet, and I'll do a little bit of hydrology. We started this off setting up our project and data folders using that drawing folder method. Again, drawing folder is a good option for you if the project you're working on doesn't have too many files. As soon as we start introducing center lines and profiles, or roads particularly, we're going to get a lot of files. So for each roadway, you're going to have 6 or 7 different files. For instance, a single roadway, you'd have an existing ground surface that you need, horizontal alignment, an existing profile, a proposed profile, existing cross sections, proposed cross sections, a typical section, plus other things. So as soon as you introduce a road, we really need to consider having all of these files that we use sorted out into more than just a single project folder, because it's a lot to sort through. So that's where the project folder method comes into play. This is going to be a lot more similar to what anybody that used Land Desktop is familiar with. So with project folder, it activates this project subfolder setup and data type subfolder setup buttons. Under project folders, I can create this set of folders and subfolders however I want, completely customize it. The top level project folder will end up being named whatever my project is, and then I build the rest of it. So you can see I've got a drawings folder and I put an underscore in front of it. That just makes sure that that drawing folder is at the top of the alphabetical list, because I go to it more than anything else. And then I've got a folder for centerline and profile files, a folder for points, for roads and cross sections, and then for surfaces. So the first time you come in here, it's going to actually look like this. And so you can build it, or I've got samples Carlson installs with sample files, I just canceled out, that you can use the load button and you can load them in. So, well, I don't have them here, but and there's one that mimics the Land Desktop folder structure. But let me also take this opportunity, I don't think I've mentioned it, is the Load and the Save As button. Just let you save. If you've got one built, you can save from pretty much any dialog box. and it creates a settings file specific for that dialog box. So you can save what you have set here and then share it with somebody, or if you move to a different computer or want to load it in later. In almost all Carlson dialog boxes, you're going to find a load and a save as that act the same way. But also, there is a master settings file called a CFG file or a configuration file that you can also save as, and it saves all your settings at that time that can be loaded in. So it's a good backup for you. So you can create this project folder and subfolder tree. And then the second step is to go to the data type subfolders. And in here, this lists every single file that Carlson creates, but you don't need to worry about all of them. Just go to the files that you know you have a place for. So CL file is for centerlines, and I want those saved here. CRD files here. Drawing files here. Any other random file that gets created, it's going to go to the top level project folder, and then you can just double click and browse to where you want to save it. So now that we're moving into centerlines and profiles, I'm switching to the project folder. I'll pick OK. I'll save this, and then I'm going to open my next file. Okay. All right, so here you can see I've got contours. If I do a 3D view, I actually have a 10 file already. So I've got a surface underneath. And I want to show you how to manually create centerline files and profile files. This is in survey or civil. I'm purposely going to stay in survey because I'm very much a fan of the fact that Carlson gives you the ability to do profiles from survey. It's just a small little set of menus here, or I'm sorry, commands here under the surface menu. But everything I'm getting ready to show you, we're going to stay in survey to do it. I'm going to start off just by sketching in a few tangent polylines. I'm going to fill it with a 300-foot radius. And then I want to define this as a centerline file. So we call it a centerline file. It's any horizontal alignment. So it can be used for anything, not just centerlines, but it's a horizontal alignment. The command is under centerline, input, edit, centerline file. So this is like a lot of Carlson's, oh, I went to the wrong place anyway. Scratch that, I'll explain that in a minute. I'm actually going to do polyline to centerline file. So I have the geometry in the drawing as a polyline. So right here, I'm just going to give it a name, CL1. And then at the command line, it prompts me to select the polyline representing the center line. It gives me these little arrows showing me the direction. So I have a chance here, an opportunity to reverse it if I want. I can also, default is starting at 0 station. I can change that, but I'm going to leave it for the moment. So that CL file's been written, and I'm going to go to centerline. Let's just station it real quick. So you can see my stationings I can set up here. I can change the formatting of the label, whatever. Now I don't have to create a CL file in order to get stationing, but if I have created a CL file, and I would mostly recommend that you do that, always use it. So if you have a CL file, use it just to keep things consistent throughout. So there's the CL file, and here's my stationing. Now let's talk about input edit. So you're going to see this across a lot of other Carlson commands is input edit this or that. This is Carlson's file dialog box. If you're going to create a new one, you can do that from here. So if you're trying to recreate a design that's already been done, you've got the paper plans, you just need to build the CL file, you can do that starting here with a new file. Or if you have an existing you want to edit, you can do that. So here, like in most things, you've got a graphic view and you've got a table view. If I want to change any of those components, I can do so. Or I can go here and make a change to the station, for instance. And you can see my station has updated. I'm just going to save and exit. And you can see that my stationing has updated in the drawing. So, very simple, not much to it. But let's move on and look at how to manually create our profiles. So in Survey, under the Surface menu, I can create a profile from a grid or triangulation surface, which is exactly what I have. This is the surface I want to sample. And pick OK. And then the profile to right. So this is my Centerline 1, and it's going to be my existing ground. Again, at the command line, it gives me an option of choosing that polyline in the drawing, but anytime I've created a CL file, I want to refer back to that. So it has created the profile. If we go to Surface, we've got Input, Edit, Profile File. So just like we talked about a minute ago, I want to look at this profile, and here's my profile editor. Same thing, I've got the graphic view up top. As my mouse moves along, you can see the information is updated. I have a table view here of each of the PVIs. But very important and very cool. It's one of my favorite commands in here because it's so simple, but it lets you do so much. Carlson has different profile types. There are 6 types of profile. This is a profile that was generated from my surface and an alignment. So really the only information it has is the station number along it and then an elevation and slope. Okay. If you have different profile types, you get different headings at the top. You always have the original station, elevation, slope, but for instance, when we switch and say this is a road profile, which doesn't fit, but you can see you get vertical curve and sight distance. When you have a sewer type, you can see you've got pipe size, rim elevation, manhole ID, and so on. So we're going to come back to that, and that's going to be real important to us. But for now, we're just going to save this as an existing ground profile, exactly as it was sampled. And I am going to add a proposed ground profile over top of that. So this will be going into the same place and just telling it I want a new profile called CL1PG. So this is brand new. I need to build it from scratch. But unless you are going strictly from paper plans that you can key all this in the table, if I'm actually trying to design from here maybe, I would like to see my existing ground profile in the background, and I can do that here. You can see the reference. Well, before I do that, notice the profile type. If you go in and you create a new profile from scratch, it defaults to road, which in this case turns out to be exactly what we want. But the reference profile is going to be my existing ground. So while I can see it and I can reference it, it's not active. I can't move my cursor or anything. But here I can see my beginning and ending stations. And as I design this new proposed ground profile, I'd like to tie in at the start and at the end to existing ground. So this is my first station, so I can type in 1,000 for my starting station, and it's going to tell me what the reference elevation is. Well, this is cool how this works. So if I know I want to start my proposed profile here, I'll set my station, and then I can type in that reference elevation. But notice when I type it in, it tells me over here what the depth is. So just kind of keep that in mind. If I want to tie in at exactly my existing or reference elevation, I can just type a 0 here and set the depth to 0, and it reads that exactly. So let's go to the end and just put those in first, 2689.8102. I can see it, so in a way I don't actually need to do this. I can just go up here and enter my station number. Oops, if I can do it correctly. And now I know I can just go right here and set the depth to 0, and I have kind of a generic proposed ground profile from start to finish. If I want to add a PVI, I can add a row, and I may add that at station 200, and maybe I want to set this one using a negative 2.5% slope, maybe a negative 2% slope, looks better. I can put in a vertical curve of maybe 300 feet, and that's it. So again, you can use this for design. I'm probably going to show you a better way to design here in a few minutes, but definitely if you're taking paper plans and need to get them in here electronically, this is the way to go. All right, so I'm going to save and exit. So under Surface, I want to draw these profiles in the drawing. And I can add, and it gives me the option to do it one at a time, so I can do one at a time. I also have a button to do multiple. And then here's my Draw Profile dialog box. So I want it to draw a grid. Let's look at the setup. And just very generic, I've got 50-foot horizontal grid, I've got major grid, my verticals here, all kinds of formatting. You can do anything you want with this. Down here at the bottom, layers. So I can change and update all my layers. I can prefix with the profile names and things like that. I can set colors, text and symbols, line types, and so forth. But this is the important thing. Notice all these label buttons over here. These are based on the type of profile. So if we have a road profile, I can go in here and tell it how the labels for a road type profile should look. And I'm just going to accept what's there. You'll have to trust me that you can do pretty much anything you want. Let's pick OK. So my elevation range, the lowest is 924.7. This is showing an elevation of 920 for my bottom grid. I'm going to change that to 910 to make sure I've got room to get some pipes in there. And we got it. So here it's nothing fancy. I may need to change it, but you can get the gist of it. So on top of this, I want to add like a storm run of pipe, and some crossing structures. So I'm going to use Input Edit Profile File again. This will be another new one, and this will be for storm. My reference profile in this case, I'm going to reference my proposed ground. And again, you may have paper plans you have already to recreate. I'm just going to kind of swag some stuff in here. Let's say that I'm going to look at station 1600. And I can see my reference elevation. I'm going to do one at 2000. And then I'm going to do another one at 2250. So my first one is going to be at station 1600. This is a sewer type, so I almost forgot to change that. 1600. So the elevation in this case is going to be actually my invert. So I'm going to skip over here and set my rim. So my rim, I think I have to type it in here. My rim is going to be 937.47. Manhole ID, this is going to be number 1. And then I want to just set it by default for 6 feet. And you can see what it looks like here. My next station will be at 2000. I'm going to do the same thing. I'm just going to type in the rim according to the reference elevation at the bottom. This will be manhole 2, and I'll set it to 6 feet. And then I'll do my last one at 2250, 931.14, manhole 3, 6, and there we go. So the only thing I need to add is the pipe size, so let's just call it 18-inch RCP for both. Very simple. I'm going to save this and exit. And then before I draw it, I'm going to go back in. I'm just going to repeat this one more time, and I want to show you that you can also add crossing pipes. So this is going to be a crossing type, and loading in, I will do my proposed ground surface, my road again. And I just want to do something that doesn't really conflict with anything, so I'm going to put this in at like 1275. Let's see what my elevation looks like, just to swag that in. So this, I'm going to set this about 3 feet below. So let's do, I'll do it lower than that, 938.6. And pipe size, we'll just say it's a 6-inch water. Save it, exit. All right, now let's draw it. So I've already got my existing ground and proposed in the drawing, so I don't need to do that. I'm going to clear this list and add multiple. I'm going to add my crossing and my storm. Pick OK. So sewer pipes, this is what the labeling looks like. I don't really have much. Draw manhole name, do something like that. Pipe crossings are going to look like this. Oh shoot, let me cancel that. So the other thing is I want to keep the grid that's in here. So I'm just going to uncheck where it says draw grid, and then you'll see what option that gives me now. I've got an option now to draw an existing grid, only because I unchecked grid in the previous screen, and I can pick anywhere here, and it just adds it. So I don't need to know the scale, I don't need to know anything. I would redo that. So all this was in survey. It can be done in civil. I'm sure it can be done in takeoff as well. But I just like that you can do that in survey. So I'm going to close these previous drawings. And next, I want to show you all about Carlson's RoadNet. So this is, we're just going to start from a drawing. And this is when you are actually in the design process, and you can use it for a single road, and it would probably be very helpful. But absolutely, if you have intersecting roads, more than one road, this is the way to go. The only thing you need to start with is an existing ground surface, and you need your center line sketched in, preferably geometrically nice and neat, perpendicular, things like that. All I have here are elevated contours that were, I think, copied in from GIS. So they're not great. If you're doing a real design, you want something more than just contours, but we're going to take what we have here, and we need to build a surface from those contours. So I'm going to switch over to civil because I'm going to need to be there, and go to Triangulate and Contour. And you've seen this. I'm going to have some different options, but my 10 file, and I'm always very specific. I don't really trust, we'll do EG by contours. Surfaces from contours are not optimal, so I always put it right in the file name so I know how much or how little I can trust it. Also down here, I love that Carlson gives you these options. They understand that creating a surface from contours is not great, so they give you some additional adjustments that keeps high points and low points from being flat and things like that. I don't need to see contours, I've already got them. So no labels, selection, that's all good. It's going to ignore 0, so I don't have to worry about my center lines being picked up. I do see errors. This is more in the interpolation, and everything is a vertical problem, very little, so I'm not going to worry about those. I am going to double check here to make sure what my surface looks like in 3D. And I don't see any busted elevations. I don't see anything that caused me grief, so I'll just go with this. So just as a check, these are 0 elevation centerline polylines, and we're going to use that to do our road network. So this is under roads, road network. Road network to process. So it does create that RDN file, and I'll just call it and put today's date. All right, so we're going to work in this dot dialog box. The first thing we need to do is go to settings. The existing surface, so I don't need to sample along the center lines or cross sections or anything like that. I just give it my whole existing ground surface. Process on updated design files, I have set to prompt. That's going to annoy us going forward. But throughout the program and any of, especially these network type deals in Carlson, they're going to give you an option to turn off the automatic updating or turn it on altogether, which is auto, or set to prompt. So if I, accidentally change a center line, I may say oops and want to hit an undo. So if it prompts me that something's getting ready to change, I want to know that before it does it. Output options, triangulate and contour. This is my proposed surface. So I do want it to create a PG, and this will be road. So this is going to be a surface proposed ground just along my roads. I will have it draw contours. And then I want it to create another surface for me as well, merge road with existing. So this is going to be EG, PG merged. So if I need to take this forward and do any kind of hydrology design, I want to combine those surfaces. So it didn't give me any other kinds of, drawing contours or anything. If I want, again, Carlson does a good job of coming from the field for existing information to the design office and then back out to the field for construction staking or machine control. So you can write a SurfCE stakeout file. I'm not going to do that here. We'll circle back around to elevate pads and lots later. And then I think that's all I need here. It's always important to, the changes we're going to make are mostly going to be in that RoadNet file. So as you do things over here, make sure to hit the Save button. And that saves the RDN file, because we're going to do a lot here before you ever see anything here. So I'll start by screen picking a polyline and then assigning a center line to this. So I'll do CL1. So that was my CL. You can see it showing up here. And then the next thing, it prompts me for a new file name for the proposed profile. So you can see it created it. I haven't designed it yet, so let's look at the editor. So this did the same thing that we did in the previous exercise. It started my proposed grade at existing ground at the start and the end, and it's actually tied to it, okay? I can go in and just click here to add a PVI by screen picking on the screen, so I don't need to know elevations. I can just pick what I see and set a vertical curve. And maybe I'm going to add another one up here. Okay. So it's a roller coaster. This is when it's fun, just kind of demonstrating. I can use this button to edit that PVI. Okay. The PVI edit mode can be constrained. You can hold the slopes, you can hold station or elevation. Like in the previous exercise, as I move along the profile in the graphic view up here, I can see station, elevation, slope highlighted and displayed above. But it's also tied to the CL file in the drawing, so I can see where I am plan view while I'm moving along in profile. So I am going to click save on this and then back to my road editor. So notice up top there are 3 files that are required. I have to have a horizontal alignment, I have to have the design profile, and I have to have a template. So let's go in and do the template. So this is going to be my typical section. I'm just going to call it main. And then again here I'm going to edit and create this. So this is where it's prompting me, and I'm not ready for it to prompt me, but it keeps prompting me. So I'm going to design this template from the Centerline out. So I'll start with the grade element that's going to be a minus 2.08% from the center line to the edge of pavement. It'll be 13.5 feet. And then I'm going to give it a unique identifier. So that template point is called EP for edge of pavement. And that's what it looks like. I'm going to add a curb section. So I've got 4 different types up here that I can choose. And then I can change and fine tune all the dimensions. For this, I want to change the width to be 24 inches, and that's going to put my base at 30 inches. The material is going to be concrete, so I'll be able to pull material quantities from this, and then this will just be BOC for back of curb. Again, this is important to notice that we have save and load buttons in everything, so you can save out your curb styles to be recalled later. You can also save out the whole template here to create your library. So here's my curb. I'm going to add another grade element that's going to be like 4.17 positive for, let's say, 4 feet. An ID point that I'm just going to call SH for shoulder. So those ID points we want to be unique and simple, brief. From there, I'm going to add my cut slopes. So I'm going to keep simple slopes here, but you can have them changed based on the depth of cut or fill. You can force a berm, you can put a ditch in. On cut, oh, that was cut. On fill, I'm going to keep this simple, but again, notice you can force a ditch, you can add guardrails, add a berm, all kinds of things, but this is just a simple slope extension. Now we need to add some depth to our subgrade. We're going to have 2 inches of asphalt and then 8 inches of stone underneath. So vertical offset is going to be 2 inches. And I'm going to tie this asphalt subgrade to my edge of pavement point. So rather than put 13.5, which would force the asphalt to stay at 13.5, even if that edge of pavement shifts out for a turn lane, I want to put EP here, and it's just going to tie it all together. Material is going to be asphalt. And then I'm going to add another depth of subgrade. So this vertical offset, if I want 8 inches of stone underneath the 2, this is actually how the bottom of that stone. So I'm going to put 10 in here. And then the distance, I want it to actually go a foot behind the curb. So this is going to be EP plus 3.5. Again, by tying it to that edge of pavement, if the edge of pavement deviates from being parallel to the center line at any point, my subgrade is going to follow it. This will be stone. Oh, that's great. So you can see that that subgrade was set to go straight up, and just tie into the top of surface, okay? I've got an option here. If I double click, I can also have it wrap around, and maybe I want it to wrap around for 8 inches, and I can have it look like that. So you can build these templates pretty much however. Again, you can save pieces and parts, always recall it. Now, for Centerline 1, I have those 3 required inputs. Let's go back into my profile viewer. And now that I've got my sections, I can get some more information from this. I am on a laptop screen, so it's not perfect. But now that I've got sections, pull that over, there we go. You can see I've got cut and fill numbers at the top of my profile. Also, if I can position everything right, I can see a plan view, a profile view, and a section view. And these cut and fill, these volumes are live. So if I change, that, you saw that update, okay? Now, let's also, again, pay attention. Right now, the way I've designed Road 1 is that it's going to be a fill section coming in to where it ties into Road 2. And that's going to update, and you're going to see what I'm talking about when I say we're working with a network, not just a road design, but a network of roads. Not going to update yet. Nope. Okay. Now, we've only got one road here. We have no intersections. In RoadNet, you don't create any intersections. They are identified from the geometry. So when I screen pick a polyline for Road 2 here, and then I assign a center line, as soon as I give this a name and hit save, you're going to see intersections populate because it now recognizes that. So I have a CL and I have a profile. You can see here. Now, because Road 1 dead ends into Road 2, Road 2 is my primary road because we want its template to carry all the way through that intersection. So look what happens. Our default profile for Road 2 does what it did the first time. It ties into existing ground at the start, it ties into existing ground at the end. And so look at what that left us. The profile for Road 2 is significantly in a cut section. So now that we've added Road 2, we want to go back and let's look at Road 1, and you'll see that it has indeed, once we added Road 2, the intersection changed and dropped so that it meets the elevation of Road 2 there. I'm going to double click, even though it creates it, you can go in here and you can edit it, but you can see where the primary road is selected. So when you have one road dead ending into another, it's kind of assumed that the one that goes straight through is going to be primary. If you have a four-way intersection, you may need to go in here and change to the one that you want. While I'm here, also notice that each intersection, you've got a profile. So this is, never mind. It's there, you just can't see it yet. We'll come back. Can't see it yet. So I'm just actually gonna hit OK because I didn't change anything here. So that's our first intersection. Let's go in and edit this profile. So same way we did before, I'm just going to pick a new PVI and give it a very short vertical curve. We're back in fill, and so if we understand things correctly, we should see the profile of Road 1 has been adjusted to where it's fill. So that's how that network works. All right, we're going to add Road 3. There's not a lot to do because the profile is going to go kind of straight uphill, but it is going to give us another intersection. We can look at that profile. So that's it. So that's our proposed. We're keeping the same template for everything. So I'm going to hit save on my road network, and then the last thing I want to add are cul-de-sacs at the end of road 2 and the end of road 3. Very easy. I can do full left, full right, or I can just enter the bulb and the fillet radius and it'll be straight on. Same thing again. And it remembered everything. Pick OK. All right, so I am good. I'm going to process now. And it's not pretty, so like I said, for demo purposes, I usually just kind of design a roller coaster look out of this. But you can see what we've got. If I look at my report, you can see all of my quantities. If you zoom down, it breaks all the dirt number down into end area sections. It breaks every piece of every road down, every intersection, every cul-de-sac, everything. Let's see, what else do I want to show? We can always draw our typical sections, which this is just always fun to me because it's always a pain to draw these manually and to make sure you get it right. But if you insert this into your detail sheet and it doesn't look right, then your design is probably wrong. What else do we have? If we go to our 3D viewer, we have 2 surfaces. So here's our PG road. So this is what our road looks like. We can look at our merged surface, and this is what it looks like. And every time we process, it's going to update. So everything is very dynamic. So if I go in and decide that I do want to, make this a little easier to work with, I may want to go in and just delete that PVI. So I can remove a PVI. I may just take this one and drag it back to here. It's not where I meant to drag it, but drag it back. I can save that. I can exit. Let's just redo everything. Okay, while I'm here, I don't want to forget, because I started this earlier, all your intersections, you do have a profile for each corner of each intersection. So this can be changed, just like every other profile. But I want to show a couple more editing things that we can do, or design things that we can build in. I'm going to use this, which is an erase by layer, and see if I can get in here. I want to just delete the contours and the labels. So when we do, I'm going to freeze that too. So when we do this design, it draws the contours, but it also, these are all just break lines. So if I view these in 3D, if you're somebody that's been doing grading for a long time and you're comfortable with it, you can go in and just manually manipulate these and make changes. So what I want to show you here is, let's just erase these. And that one too. Okay. So I'm going to turn on 3 other layers, and let me show you what else I have in here. So I have this polyline, which is a widening of the edge of pavement for road 1. So if I want to kick this out, I want to have my edge of pavement follow this alignment, and I want to show you how to do that. I also have, and what I'm going to do on this will end up adjusting my surface, template, everything, quantities. What I'm going to do here is, this is a 0 elevation building pad, all of these. these are zero elevation lot lines. So I want to use my RoadNet design to elevate these polylines. It's not going to build it into my surface, but once I elevate them, I can then start working on my surface. So I want to show you how to do all of that. Let's actually do the widening up here first. This is going to be an edit to Centerline 1. So notice here are our required inputs and here are our optional ones. So we can do any of this that we want. To add this as an edge of pavement, it's going to be a template point centerline. So our template point is going to be EP. Remember that place on our template. So what we're going to end up doing, it's Centerline 1, and this is going to be a right EOP. And if we add, we go up here, template point ID. So we're picking a point on our template, which is edge of pavement in this case. And we want it to follow this. It's going to be a centerline file, but I'm going to do it by screen picking first. And then assigning a centerline. I always do this. And I'm going to do CL1 REOP, right edge of pavement. It's going to change the alignment on the right. And I'm going to save that. And I'm just going to pick OK. Let's go ahead and process that, and you can see. So it's recreated all those new surfaces for us and everything. Surface file viewer, like that, and you can see. All right, so let me explain. This is where I was going earlier. I did a bad job. Let's see, it's clear. Select layers from screen. Let's just get rid of these contours again. Okay, that's close. All right, so what I'm going to do here is I'm going to say I want to elevate my building pad, and I want it to find the highest point or the lowest point on the shoulder polyline and set my building pad maybe 2 feet above it. And then on my lot lines, I want it to find the elevation at the shoulder, and I want it to go up at a certain slope, and then flat for a certain slope. And then at the back end, I want it to tie to existing ground. So this is not going to be great for grading wise, but that's how it's going to work. So under output options, I'm going to elevate pads and elevate lots. So elevating pads, I did this earlier. The reference template, it's going to find the SH point on my template, and it's going to find any polylines on this layer within 100 feet of the shoulder. It's going to find the highest elevation, and it's going to set a vertical slope 2 feet above. So that's what all that is. New polyline on layer 3D building pads, keep the originals. Elevate lots, I don't know if I'm actually going to do this right, but grading rules, I have to set a file. And then edit. So front slope, I want it set, I don't know that that's going to come into play. Distance and vertical. So let's see, left side here is cut conditions, right side is fill. So what I want it to do is come off my SH, and I'll tell that in the next one. I want it to go for, let's say, 30 feet at a percent at a ratio of 5 to 1. And then I'm going to go, let's say, 60 feet. Vertical 0, so I want to go flat for 60 feet, and then here at the back edge it's just going to tie to existing ground. I'm going to use this button to copy all that over here. I don't know if this is right, but we'll see. Okay, so those are the grading rules. So it's going to apply those grading rules from template point ID SH. This is my 2D polyline, this is my 3D polyline layer, the front has to be within 10 feet. So my polyline has to be, lot line has to be within 10 feet of the shoulder. I think that's right. All right, so I'm going to hit save. Let's reprocess and see if we get elevated pads and lot lines. And yeah, the layer color is the same, but we've got everything elevated. Here's this. Let's go in, annotate, label polyline segment, slope, selection, that's fine. Oh. I'm not sure if I did that right. Anyway, let's look at it in 3D. Oh, I know why. Okay, well, that's why. There was still a big slope there. Yeah, well, you get the idea. Okay, so I think that was all I had on RoadNet. And last, crossing my fingers, hope I get through this. I actually had some pretty bad technology luck the last couple days. I probably shouldn't jinx it, but I am going to open my folder with hydrology and my little drawing here. Okay, so let's set this. Okay, so here, let's see what we've got to start with. I have a surface of composite, which I want to use for my drainage. So I've got my roads designed, and then I've got my existing ground surface in there. Everything's merged together. I do have a Centerline file for this road. So if I input edit, I can see that Centerline of 1. I can see my preview, which makes it nice. Okay. So, and then I'm going to just I've just kind of pre-spotted places where I could put inlets. And I think I'm going to skip this one. I'm going to add another one down here. So I'm going to switch to Carlson's Hydrology menu and go to Network and my sewer network settings. Network type is going to be storm sewer. Okay, so it's going to give me the ability to see inlets. Network file, I'm going to set up a sewer network file. Okay, surface file, I want it to reference that surface. Link sewer network to reference surface and center lines. I've got that off because in this case I don't have a full road network or anything behind it. For design, I am going to design upstream to downstream. So I'm going to start up here and go down. This will be my outlet. Let's see, auto set all my pipe sizes. I can go back and change it if needed. Auto match pipes at junction. Auto connect structures, that's fine for what I'm doing. It's very simple here. So what I am doing, I'm not going to be designing at all. I'm going to show you more drafting. So I am going to skip completely out on the design side. I will have Mark Long. I'll refer you to Mark Long or contact me to get in touch with him. For that. He's so good, and so I just kind of gave up trying to keep up. I do have to set a rainfall library, so I will set that. My pipe design criteria, I can set minimum, maximum cover. I can set velocity. I've got a drop across junctions, usually 1. Pipe at junction, I'm going to match my crowns, so on and so forth. And I think that's about it. Showing my slopes as 100%, and I think I'm good. I don't know why it always says that. Okay. All right. I am going to create a sewer structure by screen picking. And so this is reading my surface elevation. So my first one, I'm actually going to just pop in over here. And you can see that this shows up. Most of my work, again, is going to be done in this doc dialog that is saving everything out to that SEW file. Structure name is manhole 1. I do have an inlet here with a box underneath. So I've got some things that are pre-made, right? Combo grade. So it is a grate and an inlet. So box underneath, I am going to make sure my symbol, I can't see my symbol very well from there. But the reason I have a center line is to get that symbol to rotate according to the alignment, okay? So the reference center line I will specify with my CL file that I had created ahead of time. And so I can see that inlet in there. But down here I can tell it to rotate that symbol parallel to the center line. And it just takes some practice and doing this a few times of knowing whether it's parallel to center line up or downstream. So it's read the rim elevation. By default, it's set the depth at 4, which is fine for this. So I am going to hit the save button, and then I will go, no, not there. I'm going to go here and add my next structure by picking a point. And I'll just try to aim here in the middle. And you can see that it assumes the same symbol. For some reason, it keeps defaulting off the inlet. It's on the opposite side, so I'll set this center line down, but you can see the pipe is drawn here with an arrow. And so all of this can be adjusted. This is a very simplistic plan view schematic of what it looks like, but you can do all your labeling, tables, all that. So we've got that. I'm going to pick this button to pick my third point, and I'm going to go here. So that's my third inlet. And then I'll just keep on and pick a point here. Now, this is my outlet, so there is no inlet. And I'm going to change that structure to a wall, so you can see that. And so I've got my sewer network in. I'm just going to hit save, and let's look and see what we can do with this now. So with this button, I can do a quick view of the profile. A lot of us have, for years, designed in a spreadsheet type format, so if you want to make any changes, you can do so from here. If we can use these buttons to navigate upstream or downstream. So if I go upstream, I am now highlighting manhole 1. If I switch to the drainage tab over here, it keeps switching off. Save, switch to the drainage tab. When there's an inlet, you can hit this button and it'll calculate and show you, it should, what the drainage area is. I can switch downstream and run that calculation as well. So all of this is going to be based on, how good that surface is, so you can't stress that enough. You've got a pipe tab, so if you need to adjust the pipe, you can see everything here set to 12 inch. You can change that, and you do have all your hydraulic calculations you can see. I'm going to get out of this dialog box here, and let's look under network, and I just want to show you how we can view some of this. So draw sewer network, if I want to see it in a data table, I can do so. So there's two different tables. There's sewer structures and catch basins, or there's pipes. You can do upstream to downstream. You can completely configure your table as needed. Oh, hang on. I canceled out of that. Let me try one more time. Link data tables to sewer network. Oh, it was set to prompt. That's what I wanted. Oh, I got something in there. All right, got some formatting problems, but I'm just going to hit enter and go right back to that. And I can do the pipes. So that's one way to view it. We can also view 3D faces. So that is the magenta. These are the magenta faces here. What you can do with those is you can look at those in the 3D viewer. And see what that looks like. And this is, you know, pretty realistic looking. And then last, I just want to show you how to draw a profile. So when we draw a profile, we have to kind of extract that profile, that PRO, out of this SEW file that we're working in. So you can set your upstream, you can set your downstream, and then you can choose whether you're going to draw this profile or create it upstream or downstream. When you output the profile, you can just draw it, or you can save a PRO. So when we save a PRO, we can go back and manually edit like we've done before. In this case, I'm going to have it draw a design surface for me. This is the surface that I'm going to use. And then it's asking me to save this profile run. And this all looks familiar to you. If we do sewer pipes, you know, that's what it looks like. And back here. So again, there's a lot of formatting, but I want to kind of show this. You know, we do have a pipe coming out of the ground. So I do want you to see how this linking can work. So in this case, I don't know. I'm using a beta version. Oh, it worked. Good. I shouldn't have mentioned anything. That didn't work before. But when you double click on one of these labels, it should open up the way you just saw that. But let's say I want to change my location. So I don't want it to come out of the ground like it is. I want to pull it back and have that be the new location. I'll just save this and exit and then just kind of watch. It's asking if I want to update. Now that 3D view is not going to update. And you can see that's updated. Yeah, it needs to be at 0, doesn't it? Well, let's just edit it. We're almost done. So that is it's an outlet. So we don't need a 4-foot depth. That's what we need. Try one more time. There we go. Back out of the ground, but that's okay. All right. I think I actually made it. So appreciate everybody sticking in with me. I'm going to try to get this posted and up and out to everybody that sat through the other day. So if anybody has any questions or would like to follow up with me, please do so. Get back to my information. So thank you, everybody. Look forward to hearing from you. Bye-bye.